We built 3 molecules. We built this, whatever it is. We don't know what it is. What's this one? Do you remember?
Water.
Oh my God. That's a water molecule? It looks like Mickey Mouse. You knew that? Wow, that's amazing.
I want to build something. I'm going to open this today.
What is this? What does this kit do?
You can build it and put it together.
Yeah.
See all these? You put these in the wrong places that you can't get them out of there.
Yeah, you can. But what do they represent? Do you know what they represent? They represent atoms, and you can build molecules from them.
Yeah.
Should we try? You want to build some?
Yeah.
Okay, just a minute. Just a minute. Here's what we're going to build. We're going to build sodium hydroxide.
But guys, I want to build this cool thing.
Okay.
Because they're all over this. It looks cool.
Yeah.
And you know what it is?
Let's build a sodium hydroxide. Okay?
Okay.
All right,
This
so
one.
well, we need a couple. I want to show you something now. Here's this is a hydrogen. Look, this represents a hydrogen atom. This represents an oxygen atom. And this is going to be our sodium atom. Okay?
I'm going to put it together.
Oh, wow, you're doing good. Let's see. Yeah? And then attach that to the oxygen. Let me see. Let me help you.
I got it. I got it.
You got it? Okay, now put the oxygen on there. You do it. Take it. Whoops. Actually, wait. Use this one instead. This is the correct one to use. Okay? There you go. The long flexible ones are for double bonds. This is a single bond. Now hold that. And then a sodium hydroxide molecule has a sodium atom attached to it, like this.
Okay.
Look,
Do you know how to build it?
there's only one place it can go. You see that? It can't attach to the hydrogen. The hydrogen is already taken up by the oxygen. So look. So this is our sodium hydroxide atom molecule. Okay?
So let's put two.
So what's going to happen when we expose an aluminum? We have an aluminum atom. Okay, this is our aluminum. Okay.
If we attach it to here, what are we going to make?
Well, what's going to happen when we take the aluminum and we put it into the sodium hydroxide solution? Well, first off, when we put the sodium hydroxide in water, guess what happens? Pop, the sodium atom pops off. Yeah. And then, well, we don't need that. We don't need that. Hang on. When we put the aluminum into the sodium hydroxide solution, boom, look at this. So the aluminum grabs onto three hydroxide ions. And you know what happens when a bond is formed? It releases energy. Can you believe that?
But if it looks like
And so when this aluminum atom gets torn from the aluminum foil and it forms 3 bonds, you know what happens? It releases an explosive amount of energy and it heats up and yeah, go ahead. And what happens is it produces hydrogen gas. So you have all these hydrogen gas atoms. Look, see all the hydrogen gas atoms that were liberated? And then they float up in the air. And then we're going to light them. And you know what they're going to do? They're going to go pop.
how?
Because hydrogen loves to react with oxygen. So let's build an oxygen, let's build a H2O model right here. All the liberated hydrogen is going to become oxidized and it's going to become water when we light it. It's going to go boom, pop.
Come on.
Wait a minute.
It's not going to come on.
See, we're going to create a bunch of water molecules. Okay? They don't attach there. Wait a minute. So we're going to end up, when we put the aluminum in the sodium hydroxide solution, we're going to end up with a bunch of bonds being created real fast, and that's going to generate heat, and it's going to liberate hydrogen gas. And when we light it, the hydrogen gas is going to bind to the oxygen in the air, and it's going to create an explosive release of energy. And then it looks like this. Do you know what this is? I know it looks like Mickey Mouse, right? But do you know what it really is? Hold it up. That is a water molecule.
Yeah, guys, and
Tell people it's a water molecule.
it's a water molecule, but it doesn't go here.
No, it doesn't go there because it's formed in the air. And the hydrogen really loves oxygen. They love each other so much that as soon as they see each other, they grab onto each other, and they make a lot of energy. They get all excited and they explode. And what the result is water. Isn't that cool?
Mm-hmm.
It's a little bit dangerous, but let's save these. Let's save these for later, okay? And we can have them on the table when we do our chem lab in a few minutes, okay? Show the people what we're making. We're making this. I don't know what it is.
Me too.
You neither?
So guys, do you know what are we making?
Are you talking to the camera? Yeah, okay.
Guys, do you know what are we making? We don't know, but this is where's leaders. Dot.
That's a molecule, right?
Mhm.
Yeah.
Come on, can
Come
you
on.
stand up?
Come on. Oh, no. Just here. Leave it there. Now we're gonna, wait a minute. Let's not lose track. We need a blue. Alright, now where are we?
And the second one, it has to be easier.
Just a minute. Now that's way over on the other end. First, we need another. Oh, we got too many.
Okay, anyway.
Oh, no, that's right. Just a minute.
Anyway, because
This is right.
put
Okay.
the lid here. That's why.
All right, you can work on that end, and then we'll link them together. Okay.
Where is it?
You need to put that to a here's a carbon. Link that to a carbon.
Guys, it's taking so long here. I'm just waiting.
Well, you
here.
wanted to do it.
Okay. Taking so long. You need to put it somewhere.
Just a minute. We're almost there.
The green's supposed to be tiny.
Look, I'm almost there for you. I almost have where you're going to put it. Look, you got your carbon with your oxygen on it. Give it to me. Look, it goes right here. See that? It goes right here. Show the people at home where we're at. Show them the picture. Show them the picture.
Guys, you see?
See, we're almost done.
Yeah.
We don't know what this molecule is, but we're almost done with it. All right, wait a minute. Now we need a... we're so close to being done. So close.
And of course,
What's the yellow? Show me on the back. What's the yellow? What does that represent?
yellow? You need the yellow bottle, but I think
No, look on the back. It tells you what element it is. The yellow.
yellow.
Look on the back. There's a legend. Yellow is sulfur.
Okay.
Yeah. Isn't that cool?
We're getting close.
We just built a really big molecule that has sulfur.
We are done.
Show everybody at home. Show them the picture. Should we check our work?
Guys.
Should we check it? Here, show it this way. I don't know what that molecule is, but we built that model of it. Here it is. Hold it up. You gotta hold it from both sides. Yeah, that's a big molecule with, it has sulfur. It has a sulfur atom and a chlorine atom and a bunch of carbons. How many carbons does it have? Let's check this out. How many carbons are here? 1, 2, 3, 4, 5, 6, 7, 8 carbons. Ooh. All right, we just built 3 models. I'm really proud of you, sweetie. We built 3 molecules. We built this, whatever it is. We don't know what it is. What's this one? Do you remember?
Water.
Oh my God. That's a water molecule? It looks like Mickey Mouse. You knew that? Wow, that's amazing. And this is what the aluminum... Wait, this is... So when we do our experiment later, this is what's going to end up in the solution. It's an aluminum atom attached to 3 hydroxides.
Okay, I'm going to build my own. Okay. I'm going to put someone on top of there.
You're going to put another carbon? Or a nitrogen? You going for the nitrogen? Oh, the blue? The blue is the dark blue. That's a bromine.
I'm using bromine.
Yeah, that's a bromine atom. Keep going. Are you done? Just a minute. There we go. You got a pretty cool molecule going there.
It's like a mouse, kind of.
A mouse? Yeah.
Like a robot mouse.
I wonder what that molecule is.
I need another.
You know, I'm pretty sure that if you could create it with this model, that it could exist in the real world. You understand? And maybe one day you can create it when you're a famous chemist. And maybe you can win an award for creating the little mouse molecule.
I made a mouse.
Oh, that's your mouse?
Yeah.
Yeah.
My pen mouse. I'm going to put another way.
Tell you what, we've built a bunch of models here. This is a really cool kit. I'm pretty happy about, pretty pleased with this. I'm pretty pleased with the way it goes together. The only drawback of this kit has been that even before we opened any bags or the lid doesn't attach really well, and with a toy like this, it's not a toy, see? So that's the problem. Kids treat it like a toy, and then the pieces are going to go missing because they're going to try and mix it with their Legos and everything. But on the other hand, it wasn't very expensive, and so I wouldn't hesitate to buy another 1 or 2 of these kits. There you go.
So I don't treat it like a toy.
No, you're a real scientist, aren't you? Are you a scientist, Marie? Yeah?
It's not going to be right there.
You like this kit, Marie?
Well, I made this.
You made that. You made this too with Daddy.
Look.
That's pretty amazing. And we made these here together.
I made the bottom
and now, Marie, you know what we're going to do this afternoon? We're going to pack this up right now, and then we're going to do another experiment with goggles and flasks, and we're going to create in real life, not in a model, we're going to create this molecule, okay? Marie?
I need a purple.
You want to do that?
I need purple.
And then we're going to create this molecule in the air, and it's going to create an explosion when we create this water molecule. You understand? You ready to do that? Yeah?